Hi guys, today's Leetcode daily is count complete subarrays in an array. So we are given an array nums which consists of only positive integers. Now it is given that we'll call a subarray of an array complete if the following conditions are satisfied. That means the number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Now there will be multiple complete subarrays possible. So we have to just return the count of these complete subarrays. We already know that a subarray is contiguous non-empty part of an array. Now we'll see example so that we can better understand this question. Like here, this is nums array. It contains three distinct elements, 1, 3, and 2. Now there are four subarrays possible that contains all these three distinct elements. So we'll return 4 as our answer. Now we'll see approach. First we'll find the count of all the distinct elements in the given array. Then we'll take a sliding window and start adding elements to it. If at any time the count of distinct elements in the window is equal to the total distinct element, this means we got a valid subarray. And from now onwards, if we'll add any further element, it will remain a valid subarray. That means it will remain as complete subarray. So we'll just add n minus high to our answer and start removing elements from left so that we can explore that more complete subarrays are possible or not. Now we'll see code. So initially we have taken an ordered map hash where we'll store the count or frequency of all the elements, all the distinct elements of nums. So, and in this count, we'll store how many distinct elements we have explored so far. So we are just traversing in nums array, and for every element, we are just incrementing its frequency. If any time the frequency of any element is 1, that means we are exploring that elements for the first time. So we are just incrementing our count by 1. Now, after this loop, the count will, after all the iterations, count variable will contain the total distinct elements in the given array. So we'll just mm, initialize total distinct elements equal to count. Now we are doing count equal to 0 so that we can further use same variable for calculating distinct count in the window. Now we are doing hash dot clear for the same reason. Now we are initializing a window, initially low equal to 0, high equal to minus 1, and initially our answer is 0. Now we are entering in while loop until low is less than n, we'll continue our iterations. If count of distinct elements in window is less than total distinct elements and high plus 1 is less than n, that means we need to add some more elements so that we can get complete subarray. So we'll just add some more element. Now if we are doing high plus plus, so that we are adding high plus 1th element, and here also we are incrementing the count of that element. If any time the count frequency of that element is 1, that means it is entering for the first time in the window, so we are doing count plus plus. If any time count of distinct elements is equal to total distinct elements, that means we got a valid subarray. And if we add any further element, it will still remain valid complete subarray. So we are adding n minus high to our answer. We are adding n minus high because we are already at high, and after that we can add only n minus high minus one more elements. So we are adding n minus high to our answer. After that we are just removing elements from the left so that we can explore more complete subarrays. So here we are just doing removing the element, that means we are decrementing the frequency by 1. If any time the frequency of that element becomes 0, that means one distinct element has gone from our window. So we'll do count minus minus and low plus plus so that we can explore further like new elements. And if at any time count is less than total distinct element but high is already equal to n minus 1, so we cannot further add any more element. So now we cannot further get any valid complete subarray, so we'll just break. And after all the iterations are done, our answer will contain the count of distinct complete subarray, the count of complete subarrays. So we'll just return our answer. Now if we talk about time complexity, then this loop is going from 0 to n. So here it is taking big O of n, and here like high is going from minus 1 to n minus 1, and low is also going from 0 to n minus 1. So like we are just exploring each element twice. So this is also big O of n. If we talk about space complexity, then we are just using unordered map where we are storing unique elements. If we have k unique elements, then space complexity is big O of k.